Alright, what's up everyone? So let's go over pset1 or cs50. Okay, let's just run all the programs first and check them out. So first we need to change our working directory to pset1, of course, to access the programs or compile it and run them. So let's start off with Mario. Make Mario. So now we've got a binary or executable called Mario. Okay. Now prompted for the height. Let's go for say 11. Alright. So as you can see, the height, I guess we could count it out or whatever, but it should be 11. So this just represents one of those Mario things in the Mario game where you jump up and yeah. Alright, let's look at greedy.c now and see what that is. Alright, first, whoops, it's a bit out of the screen. I'll clear terminal window. Alright, so make greedy. Alright, oops, greedy, there we go. So what this program does is it just calculates the minimum number of coins you would get from a floating point number you enter in. So you could enter in 10 or you could enter in 6.9 or whatever, which 6.9 would represent $6.90, 0.5 would represent 50 cents, and so on. And then it calculates the minimum number of coins you should get back. So let's go say 0.25. So that would be a quarter in US, so we should get back 1, because we should we can have 1 quarter for change, if that makes sense. So that's 1, and we can just run it again. And so 10, I don't remember what 10 is in US. 10 cents is called in US because I'm not from the US. I think it's a dime or something, or nickel. That should also be 1, because you can get back the 10 cents. Because the 10-cent coin in US exists, so it should be 1 still. But how about if we entered something like say 60 cents? Oops, let's run the program first. So 0.6, 60 cents, it shouldn't be 1 now this time. It should be 3, so because the we get 2 quarters and 1 10-cent, so that's correct. Alright, let's move on to water.c. I'll skip hello.c because both of them that one's not interesting at all. It just prints hello world, and water isn't really interesting at all as well, but we'll just go over it anyway. It's a really simple program. Just calculate, I think, the number of bottles of water you would take up on average in a 10-minute shower. That's all it does. So basically you're just multiplying it by 12, I think. That's all the program does, if I'm not mistaken. So that'd be 240, yeah. So nothing really too useful from that, but yeah. Alright, so now that we've gone over all the code, we haven't gone over the code, excuse me, just gone through running the program. Let's just dive into the code now and see how we made it possible. Okay, so this one's probably the most difficult one in pset1. So how do we go about programming this? So I initialized the int called height, hash times. What's hash times? Well, that's just the number of hashes. So let's go back to the program. Mario. Alright. So that's just the number of hashes in one row. You could think of this as one row, and that's just the number of hashes. And we start with 2 because it always starts out as 2. It's just how Mario pyramids work. Okay, and space times, we're just initializing it to 0 right now, and here we got a do while loop. And what this does is we want to keep prompting the user until they enter a valid height that's in between 0 and 22. And if it's in between 0 and 22, we can move on. Okay, so let's assume they did, and now we come to this line. This is perhaps the magic formula, or whatever you like to call it. Height plus 1 minus hash times. Now why do we have this here? This is to figure out how many spaces we need to start off with. Okay, so if we plug in the numbers, say 10 here in this scenario, it will be 10 plus 1 plus 2, and we end up with 9 spaces. 9. So although we can't really see it at all, this would be 9 spaces. Okay, now why is it 9 spaces? Well, in order to make the pyramid of height 10, the base has to be 11. So height plus 1, in order for all of these hashes to fit in, the base has to be 11. So we know then, as you can see, every row has the sum total of hash times plus space times has to be always height plus 1. Okay, that's the key thing that you need to find out for this this problem that you had to solve. That's the key thing, and the rest is pretty simple, except for one more detail that we'll go over later. But that's it. So we know the width will always be height plus 1, so we can figure out how many hashes and how many spaces we need for each row. Okay, so now we've found out the starting amount of spaces. Okay, now we can use a loop to print out the rest of the Mario pyramid. Okay, so how do we do that? We got space left and hash left. Now that just equals space times and hash times. That's just to go about printing out all the spaces and all the hashes. Okay, that's all these two loops are meant to do. That's all they do. They just so for example, space left, this will print out all the spaces required for that particular row. So in this case, the first run through would be 9, so it'll print out 9 spaces. This will loop over 9 times because space left is equal to 9. Okay, we got 9 spaces, and then we'll only get 2 hashes. And then next, you can see this is the next crucial part. Hash times always gets decremented. Space times always gets decremented, and hash times always it gets incremented in order to get that pattern that we want, where hashes always seem to increase each time as we go down the pyramid. Okay? Now bear in mind, this is just my implementation. There's lots and lots of ways you can do it yourself, and that the explanation I went through is just for my code. I'm sure though there's better and simpler code out there, and hopefully with a bit of a hint from my explanations, you can go and make a better version of the Mario pyramid. How could you make this better? Well, maybe make your code shorter and easier to read. Okay, or maybe you could even implement a recursive function that would tidy everything up even more. And it's really up to you what you'd like to do. Okay, so let's move on now.